This question, we have two blocks. It's frictionless surface. We have a collision that looks like it's going to happen, so this is going to be about conservation of momentum. Initial velocity of v0, blee, which is stationary, so v0 equals 0. Collide, stick together, move off with a velocity v0 over 3. Which one has a greater mass? Well, the first thing is we should expect that this thing is a sticky collision, which means it's inelastic, and the kinetic energy is not conserved. And that's because the momentum on this side is the initial momentum, then gets shared with the two systems. So the momentum that's being carried with this mass is now being shared with that mass. So we could, which one has the greater mass? Oh, we could reason this through without getting quantitative. That we would expect that if this had the same mass, this were m and this were m, then we would expect this to go off with a v over 2. But v over 3 is less than that. So this is 0.5 and this is 0.33. So considering this, that if they were equal mass, the momentum that's contained in A would now be shared with AB moving off to the right, and that means that the velocity would be half as much. But it slows down more than that. Well, let's imagine that B has a much, much smaller. Let's say its mass is almost 0. When A collides with it, its velocity will barely change. If the mass is very tiny of B and A collides with it and they stick together, the velocity will be very close to the initial velocity. As the mass of B gets bigger and bigger, the velocity that they come away with gets slower and slower. And when we get to equal masses, they go off at half the speed. But it's more than that. The decrease is more than that. It's going off at 1/3 the speed, so B must have a greater mass. And that is this one. And we could demonstrate that algebraically, which some of you may do here. So P0 equals P. Beforehand, we have MV0. We'll call this M, and then we'll call this MB. M0, and the momentum afterward is going to be M plus MB times this new velocity, which we are told is V0 over 3. And what we want to know is how the different masses compare with each other. Well, we have 3, cross multiply, 3M V0 over V0 equals M plus MB. V0's cancel, and we're left with 3M equals M plus MB. Subtract an M from both sides, and we get 2M is the mass of the B. So mass of B is twice the mass of the other one. So we can prove it algebraically as well.